Vaccines play a vital role in our everyday life, though the stories of those who design them are often not included. Grace Eldring and Pearl Kendrick are attributed with the development of the pertussis, also known as the whooping cough vaccine. Women and other minorities are especially prone to being forgotten by both science and society for their efforts. Today, we bring them back into the spotlight. In 1900, Grace Eldring was born in Rancher, Montana on September 5th. After contracting whooping cough herself at the age of 5, Eldring was inspired to pursue a career in science. After graduating high school, she went on to achieve a bachelor's degree in science at the University of Montana, but not without setbacks. After her first 4 semesters, Eldring had to drop out due to financial restraints. She was determined to finish her degree and later made enough to return and officially graduate in 1927. For the next year, she would go on to teach biology at Hysham High School before realizing she wanted a different approach to a scientific career. She received a call to volunteer at the Michigan Bureau of Laboratories, and after 6 months, she was officially hired to conduct routine bacteriologic analysis. In 1932, Kendrick asked Eldring to join her in Grand Rapids to conduct research on a virulent strand of B. pertussis that was actively infecting children. This was the start of their collaboration that would lead to breakthroughs in vaccine research and an effective whooping cough vaccine.
On the other hand, Pearl Kendrick was born on August 24, 1890, in Wheaton, Illinois, to Mother Ella and Father Milton Kendrick. At the age of 3, Kendrick survived a case of pertussis. She attended a high school in Sherborn, New York, and graduated in 1908. After graduating, Kendrick attended Greenville College in Greenville, Illinois. 1 year later, she transferred to Syracuse University in New York, where she majored in zoology with a minor in philosophy and received her Bachelor of Science degree in 1914. She then taught for 5 years at nearby St. Johnsville Public Schools. In the summer of 1917, Kendrick returned to school to study bacteriology at Columbia University in New York City. Through 1919 and 1920, she worked as a research assistant for the New York State Department of Health. Later that year, Kendrick was offered a promotion by the Department of Health, but declined. That same year, she was asked to relocate her studies to Lansing, Michigan, to research syphilis by the director of the Bureau of Laboratories for the Michigan Department of Health. She accepted and was promoted in 1926 to Associate Director of Laboratories and Chief of the Western Michigan Branch Laboratory at the Grand Rapids Branch. Kendrick continued her research in the summers of 1928 and 1931 at the University of Michigan, where she also studied serology and pathology. She then decided to take a leave of absence from the laboratory in order to further her education at Johns Hopkins University, where she received her Doctor of Science in Bacteriology in 1932. After receiving her doctorate degree, Kendrick returned to the Grand Rapids Laboratory, where she recruited Grace. Together, the two went on to be a scientific dynamic duo in Grand Rapids, Michigan.
This Grand Rapids lab is where Doctors Pearl Kendrick and Grace Eldring got most of the work on the pertussis vaccine done. Now, the lab was very underfunded, so they would have to come in at the off hours at night to try to take samples from infected children to try to start making the vaccine. Now, pertussis itself is not a very deadly disease as far as many others go. It killed around 6,000 per year, but it did infect around 165,000 per year from 1920 to 1932 when they started the research. Now, the big issue with pertussis and why a lot of people wanted a vaccine for it was that a lot of the symptoms were very visual and very obvious when someone was sick with it. It was obviously the cough being the main one. Now, this very obvious suffering from the infected people, and mostly children, is what caused the public outcry for a better treatment or vaccine in general. Now, 1932 is when these two women finally got started on the research for the vaccine. They would come in after hours at night, after hours, to take samples from infected children and just try until they could eventually culture the pathogen in the lab setting to finally start the work on the vaccine. Now, let's take a deeper dive into how the vaccine was actually made.
Grace Eldring and Pearl Kendrick completed the largest controlled immunization studies of the pertussis vaccine with children ranging from 8 months to 5 years old with equal distribution of age, sex, family size, and geographic districts. They found that vaccinated children communicated the disease much less than their unvaccinated counterparts. Instead of using human blood, which was common at the time, they used sheep blood, which worked just as well for maintaining phase 1 of the virus but was much cheaper. This vaccine was chemically inactivated, producing a whole cell pertussis vaccine. In time, this would be combined with the diphtheria and tetanus vaccines to give the DTP vaccine, reducing the amount of immunizations required for infants. However, the whole cell vaccine was responsible for many adverse effects, such as redness, swelling, and pain around the injection site. This caused the switch to the acellular pertussis vaccine, aka the DTaP vaccine. The DTaP vaccine is common for younger children, whereas the Tdap vaccine is common for older children and adults. Reports have shown that the acellular vaccine leads to less long-lasting immunity than the whole cell vaccine, providing immunity for 5 to 10 years after the last dose. Though both vaccines are used, the acellular vaccine is most predominant today.
Eldring and Kendrick were two extremely significant scientists in the realm of vaccine research history. Their impact on the future generation of scientists and their monumental discoveries inspired thousands of women researchers who came after them. These two women's adaptive and creative research techniques, which included using themselves as test subjects and working with a limited budget, fostered the idea that unique strategies and actions can be used to develop a pathway leading to a discovery you never thought was possible. It is obvious that Kendrick and Eldring's DTP vaccine has had a huge impact on our society because it is still routinely given in our country as a part of our vaccine cycle today. Both women continued using their scientific brilliance following the completion of the vaccine development. They both were active in a number of professional organizations, some of which include the American Board of Bacteriologists and the American Public Health Association. Kendrick taught and conducted research at the University of Michigan in the Department of Epidemiology. Kendrick and Eldring each served a term as president of the American Society for Microbiology Michigan branch. These humble women rejected multiple chances of fame they were given in their later life. Their refusal to accept traditional rewards of fame demonstrated their genuine desire to better medicine without seeking the benefits of success. Unfortunately, there has been a reemergence of whooping cough recently, and the NIH has stated that Kendrick and Eldring's research model can be useful today. The State Department of Health laboratories have recently lost funding and personnel. The historic women's model of rallying resources and support from local, state, and national communities may prove once again to be a promising avenue for innovative research. Grace and Pearl had a huge impact on not only the development of the DTP vaccine that is still relevant today, but also opened doors for women in STEM all over the world.
Another major unsung hero of the pertussis vaccine development process is Lonnie Clinton Gordon, a black female scientist who graduated from Michigan State University in 1939. She found herself working in the Eldring and Kendrick lab in 1943 after experiencing discrimination when trying to find a job as a dietitian. Gordon is attributed to having found an especially virulent strain of pertussis, allowing for a stronger, more effective vaccine. In 2000, Clinton Gordon was posthumously inducted into the Michigan Women's Hall of Fame. Information on her life and contributions are sparse, though there is no question that she played a pivotal role in the development of a viable pertussis vaccine. Although it begs the question why many sources omit her contributions. Given the time period, one can come up with conclusions for why this is, but consider it a lesson in raising the voices, actions, and contributions of those underrepresented in science and society.